So let's talk about uncertainty or margin of error during titration practicals. Whenever you are carrying out any practical in the laboratory, you are bound to make mistakes or errors. So you are not going to be 100% accurate. So we talk about uncertainty or margin of error. So whenever you are doing a titration experiment, I've said one solution is placed in the burette and another one is placed in the conical flask. So you open the tap on the burette to allow the volume in the burette to be used. So let's say the first experiment you get 15 cubic centimeters of titrant. We call it titer in this case. And then in the second titration, maybe you get 15.1 cubic centimeters, the second titer. And maybe you conduct the third titration experiment and you get maybe 14.9 cubic centimeters to be the third one, the third titer. So this is the first experiment, first titration, second titration, third titration. The reason why you are getting these different values is that you are not accurate in any particular experiment. The reason why this value is not exactly the same as this one is because you've made an error either here or here or here. So we normally allow a margin of error in chemistry. We use plus or minus 0.2 allowance. So that, assuming this one was your first value or after titration, then you get anything that is very far away from 15 cubic centimeters. Let's say 14.6. The difference between 15 cubic centimeters and 14.6 is very big. So it creates ambiguity in your values. So this one means the experiment is wrong. But if you get a value like this, which is very close to the first one, the difference between this one and this one is 0.1. The difference between this and this one is 0.1. The difference between the largest and the smallest, this is the largest and this is the smallest, is 0.2. Then we say your values are accurate. You use these values to now calculate what we call average titer, which is 15.0 plus 15.1 plus 14.9. Now, given that there are 3 of them, you divide by 3. You divide by 3. And this one gives what? This one gives exactly 15.0 cubic centimeters. So this is the average titer, the average volume of the burette that has been used in the reaction.